Hello, today I'm just going to be talking a little bit about isomers and explaining to you guys how we can learn about isomers and how we can identify and find out new isomers just using their formula. So, if I just move this out of the way. Okay, so we've got isomers, a quick introduction. So when we're looking at isomers, we just want to find out how we can identify them and what we can do to make sure that they are correct. So with your isomers, they all have the same molecular formula, okay, but have different molecular structure. So if I just write out two here, I have cyclobutane. Apologies about the hydrogens. Cyclobutane. Okay. And I have some butene. Okay, both have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they're both C4H8. Same molecular formula. Let me just fix that. Same molecular formula. Okay, but they both are different structures, as you can see, both vastly different. This has a ring structure, okay, no double carbon-carbon double bond, alright, and this one, it's a linear structure but has a carbon-carbon double bond, so it will have different properties, okay. So, we know how to identify these. It's like Lego bricks. You can have the same sort of Lego bricks, use the same things, but you can make something different every single time. So if I move on to some more complicated examples, okay, so firstly, isomers. Same chemical formulae, different molecular structure. That's isomers, okay? Making sure that that's what we're finding out each time. So they will have the same chemical formula, but they'll both have different structures. And isomers are different in more ways than one. So for instance, even if I go back to my butene, okay, or in this case, it's but1ene. But1ene. But2ene is technically an isomer because the carbon-carbon double bond is in a different place, which means it has different properties, okay? So, if I just draw this out again, sorry, my setup isn't that good for making sure they both stay in the same thing. But if I lift this up a bit, so you can see, okay, but1ene, carbon-carbon double bonds are the first carbon, but2ene, carbon-carbon double bond is on the second carbon. This means it has different properties. They're the same chemical formula, both C4H8, but they're different structures because the carbon-carbon double bond is in a different place. If I put my carbon-carbon double bond here, and I rub this out, from our naming, okay, these are both but1ene because, remember, the carbon-carbon double bond has priority. So, in this situation, these are not isomers. These are the same molecule. They are both but1ene. Okay? They are both the exact same. Because, when we're naming, we go from here 1, 2, 3, 4. And if we go from this side, that is 1, 2, 3, 4. Both have 4 carbons, both have 8 hydrogens, and both have a carbon-carbon double bond between the first and second hydrogens, which means they're both but1ene. Lovely. If I move on to something a little bit more complicated, so let's just prop this up a little bit more so you guys can see. Okay. if I draw my molecule here, you all know that this is pentane with a formula of C5H12. If I draw this molecule here, this is 2-methyl butane. Okay? Again, has the same formula. These both have the same formula, but different structures. All that's happened here is essentially you've broken off this carbon and swapped it with that hydrogen, which makes this, okay? But when we're talking about this, okay, we need to remember, just count the hydrogens, count the carbons. If they have the same number of carbons and hydrogens, but they look different, it's likely that they're isomers, okay? You just need to be wary of the naming convention, because if I drew then another one, like this, okay? This is also 2-methylbutane because the methyl group is on that second carbon. So we need to be wary of things like this, where we have something that looks similar and you think, that's different. It's not, okay? It's the exact same one. We need to make sure that we're recognizing our naming conventions and using this to identify our isomers, okay? It's just building on what we learned on before. But if I draw this molecule here, alright, this is technically only dimethylpropane, but I'm just going to be safe. 2,2-dimethylpropane. So this again has a different structure. It's now got 2 methyl groups and it's got only a shorter chain. So it will again have different chemical properties to both pentane and butane, but still has the same chemical formula. It's still 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, still has 12 carbons. So these are all isomers. If you move on and go higher and higher up, you get more and more isomers as you're allowed to change essentially the building blocks more and more. So as you have more carbons and hydrogens, the more arrangements you can have. Similar to how if you have a 6-piece Lego set, you can only make a small amount of different models. But if you have a 5,000 Lego set, you can make a lot of different models and have a lot of different arrangements. Okay, so if I go again, and we'll try something, see if I can fit it all in. Okay, so I have this. We know it's hexane. If I make one isomer, so I can only use 6 carbons, C6, oh, that's out of shot, C6, H14, because it's got the same general formula as alkanes. Let's make sure I can use all the board I need. Lovely. Alright, then we'll try one with 5. So this is 1, 2, 3 methyl pentane. I can have another isomer where it's 1, 2, 3, 4, 5. Put that there. going to run out of room very quickly. Apologies for how messy this is. Trying to fit these all in. Okay, that's 1, 2. I've got 2-methylpentane. I can then go again. If I'll rub out the 2-methylpentane and try a different one so I can fit it all in. Well, this rubber's just a little bit of tissue's useless. Okay, try again. So I can have getting lazy with my hydrogens now. Don't be lazy with your hydrogens. Make sure the bonds are joined to the atoms. Okay, I've now got 2,2-dimethyl butane there, but I can also move this methyl group along. Oh, move this methyl group along, becomes 2,3-dimethylbutane. Again, all have a structure of C6H14. Shall we double check this? Okay, if I just make that a little bit neater. 1, 2, 3, 4, 5, 6. Yep. 1, 2, 3, 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So still following this molecular formula. If I go again, and we'll have to rub out another one. Okay, and this one's going to be tricky. But if I... Can I actually do any more? I think that's it. Yeah, that's it. Because if I try and do 3 on the propene, it then just maintains as a dimethylbutane. So, there's multiple ways we can draw these isomers, but what you need to remember is that they will always have the same molecular formula, which means they have the same number of building blocks in each molecule. So each one will always have the same number of carbon and hydrogens, they're just arranged differently. So for instance, if I go again with another cycloalkane, sorry. And draw this. Okay, this is C5H10. I can draw myself a little pent-1-ene. And that works like that, so that's pent-1-ene. Just double checking it's got the same formula as that. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Dreamy follows that. Tick, it's an isomer. If I draw this, okay, that's pent-2-ene. Same again, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tick, also an isomer. So what we need to make sure is that we are always having the same molecular formula, but they always have a different structure. And just being aware that you're not getting caught out by ones being sneaky by putting the double bond in a separate place or putting the methyl group in a separate place. Please also be careful that you don't get caught out by stuff around the corner. So please do not do anything first methyl, like 1-methyl groups, okay? Because remember, that just makes the chain longer. So we need to make sure that we're not getting caught out by those. My desk is now covered in rubbings. Okay, so if we carry on doing this and we can go further and further, we could do more and more. So you could do cycloheptane and any heptenes, so hep1-ene, hep2-ene, hep3-ene. Okay, so you need to make sure that you're wary of those. There's also ones with different groups, so you can get ones with different trimethyls. So if I was to do, again, so let's just try one more, a quite complicated example. 7, fill in my hydrogens. Keep going with these. So this is, can I fit that in? Lovely. C7H16. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7. Lovely. So again, we could carry on. I'll just do some more examples and rub them out as I go. Sorry, my H's are looking horrendous. Okay, so there we have 2-methyl-hexane. If I just change this up a little bit, I can get it to become 3-methyl-hexane, which again is an isomer, because we can check this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, same again. Lovely. Take that off. If we go one step further, remove another carbon from the long chain. Go like this. Oh, I'm forgetting my bonds now. We keep going like this. Okay. Oh, I've forgotten that. Silly me. That was the exact same, but just different. Okay, so this is what's this now? 1, 2, 2, 2 dimethyl pentane. Alright, so 2, 2 dimethyl pentane. Double check that's the isomer again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7. Another isomer. Follows that rule. Excellent. Oh, I shouldn't have rubbed that out. You can also have, if we moved one of those methyl groups onto the third carbon, it would be 2,3-dimethylpentane. If I do the final variation that I think is possible, try and fit all these methyl groups in nice and tidily. Not helping myself. Oh, just knocked my camera off everywhere. So many carbons and hydrogens now. So this now is, let's name this 1, 2, 2, 2, 3. So it's now 2, 2, 3 trimethyl butane. Sorry, run out of room. So if I move that out of the way of my camera, so that's 2, 2 trimethyl butane. If I then provide another variation of that, I can then make it. Oh no, that's it. You can't get 2, 2, 3, 3. Okay, so because if this is a good one for you guys as well. If you see this, okay, where's the priority now? More groups are to the right hand side than the left, so it's now counting from right to left. So it's now 1, 2, 2, 2, trimethyl, 2, 2, 3, sorry, trimethyl butane. So no matter how many times you rearrange that, it's going to be the same one each time. So, what have we learnt from this? So we know isomers, same molecular formula, different, I'm just going to write diff, structural formula, which essentially means same number of building blocks, just different ways of building them, like I spoke about with the Lego sets. They're just basically just building them. Apologies, handwriting's pretty poor. So basically, they're all just different ways of using the same set of carbons and hydrogens and rearranging them to have the same thing. So there's lots of different ones that you can go through if we were to just go through, like, so C4H10, you've got butane and 2-methyl propane. If I did C5H12, I've got pentane, 2-methyl butane. I've got 2,2-dimethyl propane. And if I just do this, C6H14, I've got hexane, 2-methyl pentane, 3-methyl pentane, and 2,2-dimethyl butane, and 2,3-dimethyl butane. Apologies for that being a bit messy. So we have lots of different ways that, and as you can tend to have more carbon and hydrogen atoms, the more isomers you tend to get, so the more there will be. So as you can see, 2 for C4H10, 3 for C5H12, and there is 5 for C6H14. So again, hopefully this has helped a little bit and has allowed you to learn a little bit more about isomers, but the main point is that they're the same molecular formula and different structural formula, and this is the key takeaway that we need to look at. And then just beware that it's building on your naming hydrocarbons work that we did last week, and that you're going to be moving on and using this throughout the rest of the chemistry topic. All right, have a good day, guys. See you later. Bye-bye.